Next, we're going to learn about valence electrons and how to determine what the valence electrons are from the electron configuration. So I'm going to give you a couple examples. Calcium has a Z number of 20. So I have 20 electrons to represent. I'm just going to start at the bottom at the 1s like I always do. So 1s2, 2s2, 2p6, and then I have 10 of them. 3s2, 3p6, 4s2. This is the complete electron configuration for calcium. If I'm looking for the valence electrons, I'm looking for the electrons in the outer shell. So I'm looking for the electrons that have the highest principal energy level right here. So we have 1, we have 2, we have 3, and we have 4. 4 is the highest number. That is the outside electron shell. And the valence electrons for calcium are the 4s2 electrons. Now let's do another one. Let's do arsenic. Arsenic has a Z number of 33. So I'm going to fill in my 33 electrons, which we should be getting pretty good at already. After 4s2, remember that we go down and we're going to fill in 3d10. And after 3d10, we will have 10, 20, 30 electrons. We only need 3 more. Therefore, in 4p, I don't have all 6. I only have 3. And that will add up to the 33 electrons. Now, I'm looking for the valence electrons for arsenic. I also have electrons in the first, second, third, and fourth shell. So I'm going to underline all the electrons that are in the fourth shell. That's the outside shell, like that. Let's do another example. I'm going to do indium. Indium has a Z number of 49. So it's going to have all the electrons that the other guys have and then some. Let's count 10, 20, 30, 38, 48. I need one more, and that's going to be in 5p1, like such. So this time I have electrons in the first, the second, the third, the fourth, and the fifth principal energy level. I'm going to underline all the ones in the fifth. It is not a coincidence. That is the outer shell, and it is the highest coefficient. And the other thing that is not a coincidence is let's find calcium on the periodic table of the elements. You'll see that there is a 2a above its family. That means that calcium has 2 valence electrons, and its 4s2 are the 2 valence electrons. Let's find arsenic at number 33. And you're going to see it has the Roman numeral 5a at the top. Arsenic has 5 valence electrons, and the valence electrons are 4s2, 4p3. Indium has a Roman numeral 3a at the top. Not a coincidence that indium has 3 valence electrons. Next, we will learn about the abbreviated electron configuration.